you can mute your audio and turn off your video till a question and answer at the end of the presentation. If you want to ask a question during, you can use the chat. If Jim or somebody could kind of break in, because I'll be in full screen just showing my screen. So whatever works there. The handout, Jim will be putting the handout out on the chat in a few minutes there. It's also available out on the PC website and the past meetings area if you want to get a copy right now. The agenda will cover a few club status first, and then we'll get to our main topic. Future meeting, we do have a MaxSig coming up this Friday, December 18th, web only. It's a Zoom meeting, and this is their annual blowout, except we aren't all getting together and sharing food, but there'll be Apple News, Wild Holiday Virtual Fest, so you can be eating whatever you've got at home and show it to everybody else and make them jealous, so you can do that. There'll also be Mac, iPad, iPhone tips and hints for everybody. There'll be some recognitions of some contributors, and then the Mac Life subscription raffle. And then they always have questions also. On January 5th, so in 2021, we're starting to have our monthly question and answer session. So the next question and answer is Tuesday, January 5th. At 11:30, and we'll send out notices before then. And then our next general meeting is going to be Wednesday, January 20th, and the topic will be cloud storage. We'll talk about security, the difference between a private, a public, or a home cloud, backup, and some data and apps, how some of that stuff works. Our officers, Jim Holman is our president, Linda Brown is our vice president, Paul Ebert is our membership secretary, Mike Griffin is our treasurer and MaxSig. However, Mike did retire from 3M the end of November, so congratulations to him, and I'll have a slide about the treasurer position in a minute there. Chuck Scott is our secretary, and Andrew Petrucci is our communication coordinator. And my name is Tom Kreuzer. I'm a director at large. So I mentioned that Mike is retired, and because 3M Club would like to have the treasurers be active 3M employees, we're looking to fill the position of treasurer within the PCC Club. And there's not a whole lot that you have to do. Currently, because we're doing everything remotely, you'd connect into the PC board meeting held the first Monday of the month for an hour. You'd also make deposits and pay expenses for the club. We don't have a lot of money coming in and going out, so that usually isn't much of a big deal there. Maybe an additional 5 minutes, at most 30 minutes a month. As I mentioned, they want an active 3M employee, so if you are retired, sorry, but we're looking for somebody who's an active 3M employee. And so if you are interested in can help us out and become the treasurer, we'd love to have you. Even if you're just interested, you can join the next meeting, which is going to be, I think, January 4th. So you can sit in and hear and ask questions or anything that you want there. Let anyone on the board, myself or any other member, know there, and we'd love to have you join and help out there. Again, not much of a commitment, and you'd be helping the club out there. Okay, members, old and new, pay the dues to Paul Ebert, $8. So when your membership does come due, you will get a notice from Paul, and you can pay those electronically. There's a number of methods there, or you can send it in to Paul by normal mail also. Also a reminder, if you are changing your email from work or from your ISP or that, make sure and notify us, because that's the way we keep in touch for these meetings and for renewals and everything. If you have suggestions for topics, email us, talk to a board member. We'd love to have you present, or if you're doing something at home or at work, that'd be great. If you don't want to present, we have a monthly newsletter. You can write a short article or a long article. It'd be great. Website, we post the meetings and slides and handouts out there, and we usually try and record the meeting, and that'll be out there after the meeting is over. We also have a deal section with some discounts, and we have our monthly newsletter, and the link is here, but it's also sent in the emails that we send out. Currently, we have our year-end club survey. I want to thank the 40-plus people who have filled out the survey. You can, if you haven't filled it out, you'll have until December 21st, and I'll send out another reminder to one last chance to fill out the survey. We use it to make some important decisions on the future of the club and topics, and also, I use it in a number of my presentations, the numbers and the trends that I see within the club. So if you could, I'd really appreciate it. And it, like I say, it helps out everyone there. Okay, our main topic today is going to be basics of coding by myself, Tom Kreuzer. Coding or computer programming is a set of instructions which returns a desired output. So it's just simply you create something because you want to have some type of output. The process of coding can comprise multiple tasks, and those tasks are things like analysis, so you analyze the problem, then you design a solution to the problem, then you actually code the solution. Then, because we all aren't perfect there has to be some testing to see how well the coding that we did compares to what our design is. And then once testing is done, there's usually a deployment to move it into production or into how you're going to use it there. So those are usually the steps or tasks that you do in coding. There's hundreds of computer languages, each with their own strength and weakness. And so, no, there's no perfect language that works for everything. And so that's why you have so many of them. And all of them have their strengths and their weaknesses and are used by somebody for something. And these strengths and weaknesses also, there's differences in the devices and the platforms that they run on. So not all computer programs or languages run on all the different devices that we have or the different operating systems that we have. So that's why there's so many variations, and again, they each have their strengths and weaknesses. Code can be as simple as one line, in this case a formula, z equals x plus y, or it can be millions of lines of code like a Windows operating system. So the Windows operating system, because of all the features, functions, modules, and things like that, you're talking millions of lines of code created by hundreds and thousands of people that create and maintain that code. So it can be very complex or it can be very simple. Coding can also be a full-time job, and I'll talk about my experience, I think, in the next slide. Or it just can be a hobby to make your own life better and easier. So you have people that spend anywhere from full-time job to just they may create one or two programs, and the programs that they create may just be a few simple lines. So you have the wide variety there. Okay, a little bit of my coding history. Actually, I started coding back in 1973, and that was when I was in high school. And I would compute high school golf team scores and I'd use it to predict football point spreads for football games, professional football games. And this is a device that I used. So this is a programmable calculator. You had a number of keys in here, and then you had registers for storing values, and then it had a paper tape for printing out stuff. So it was kind of like an adding machine with a paper tape, except because with the registers and that, you could store values and you could put in commands. Didn't have any way to store the program, so the program and the data that you entered, as soon as you turned off the unit itself, it lost everything. So a very simple, but one of the first programmable calculators. I actually got my first PC, and it wasn't an IBM PC. It was a Exidy Sorcerer back in 1977. So the IBM PC hadn't come out yet, but I loved the programmable calculators and wanted to get involved. And when I bought this machine, the machines at that time usually came with a language, and it was the basic programming language, so that you could write your own code, or you could find in books or things like that little programs to create, and that's what you do. Storing of the data, there were no disk drives. Storing of the data was data and the code itself was done on a cassette tape. I started at 3M in 1979 as a programmer, and at that time 3M was using COBOL and JCL, and JCL or COBOL is common object business oriented language, and JCL is job control language, and we did that with punch cards and tape. So there were reels, magnetic reels of tape is where the data was stored. We didn't have any databases. We didn't have any hard drives. We did everything with COBOL on punch cards and this JCL controlling the operating system and doing stuff. In 1981, IBM came along with the first personal computer, and that included DOS, disk operating system, and the disk operating system included BASIC, and also had kind of a command language called .bat files. Over time, I've used 50 plus languages for work and for home. So there isn't, like I say, there isn't one language that works for everything. You have to, depending on the devices, depending on the features and functions, you find what works, and you learn a new language, and you learn these different ways of doing things. Okay. Today, people code without even knowing that they're doing it. So in addition to standalone languages, most of the major software and sites that we go to usually provide some way to code. And the way they do that is they may support scripts, programs, procedures, macros, rules, and other things. So that's why I say if you're using these packages and you're going in and doing things, you're doing some programming already today. Some of the sites and software let you record keystrokes for playback, while others like Excel have a complex and complete macro language with screens to manage the code, to debug it, to help you keep track of everything. Also, another thing that you see today with all the smart devices that we have in the home and things like that is you may have heard of a language called IFTTT, and that stands for if this then that. And that's a way of connecting some of these smart devices that may be from multiple vendors, or the vendor isn't providing the exact functionality that you like, so that gives you a way of combining these different smart devices and getting exactly what you want. And it makes it very nice there, a lot of flexibility. And along with that flexibility, this is just a simple example of what I do. Um, I think I've talked before in the past. I do have Alexa devices around my house, with the Alexa device, you can program, and the Alexa allows you to create a thing called routines, and these routines can interact. You can interact both with Alexa and the smart devices that you have, and so you can create all kinds of nice things there. And one of the things that I did is I had bought years ago. I had bought a smart plug, and I wanted the smart plug to turn a light on in my house at sunset. Well, actually 45 minutes after sunset, but uh, I had an old X10 system, and I was able to program with that. And so when Alexa came along, I wanted to do the same thing with these smart devices. Well, the smart device didn't support sunset, the concept of sunset. I could turn it on at a certain time, and I could turn it off at a certain time, but it didn't support sunset. Well, when I got Alexa, Alexa does support the function of sunset. So I was able to go into Alexa and set up a little routine. And this routine is triggered by sunset. And sunset is determined by your location, latitude and longitude, and it keeps track of all of that and changes it. And in this case, it triggers a routine at 45 minutes before sunset. And when the routine is triggered, this is a very simple program. It just turns the light on, this lamp on. So that's a very simple thing, but it's using a complex function and allowed me to get exactly what I wanted out of this smart device that I had, even though the smart device did not support what I wanted to do. Their app or their site did not support it, but Alexa did. This is an example of another routine. I have where I currently am. I call that my den, and I have my computer in here, my desktop computer, and I have a heater in here. And the heater, yes, I could turn it on, but sometimes I'd forget about turning it off. So I wanted to have the heater go off after a period of time. Well, I created a routine, another routine in Alexa to when I say the word heater timer, Alexa will turn on my heater. Then a function will sit and wait for an hour, and then it'll turn off the heater. So a very simple program. Turns on the heater, waits an hour, and then turns off the heater. And Alexa actually comes with about 30 or 40 functions, and you can have different triggers and things like that. And actually, this routine here, in the last week or so, I updated it, and I added another step in here. So before it turns off the heater, it actually says to me, Alexa says to me, the heater is going to be turned off. So you can have Alexa speak back to you. You can have it say anything. You can create routines when you wake up in the morning to turn the lights on, give you a news update, give you a weather update, play songs, your playlist. So you can set up all these funny, or not funny things, all these things to automate what you do or what you need there. So this is just an example of what Alexa can do for programming. This is another example. In the past, I've recommended for
Question,
backup.
Tom,
Yes.
is just how does Alexa actually turn your heater on and off? Smart plug?
Yes, it's a smart plug, and the smart plug is registered with Alexa. And then once you register it, the functions that the smart plug supports, like turning on and off, Alexa now has that capability, so it can turn it on or off. Okay. And if there's other questions, we can talk a little more at the end too about some of the things there. Because I don't want this to be a meeting about how Alexa works. I just wanted to show that there's programming capability on some of these things that people already have. You may not be using them yet, but there's thousands of procedures out there on the internet. If you Google it, you'll find thousands of procedures. You can say, oh, I didn't even think this was possible. Now I can do it. Now I can set it up. So nice little thing there. Okay, another example. So in the past, I've recommended the backup program, Cobain Backup, and that piece of software is an example where you're using these windows or tabs to define what to back up, where to back it up to, what not to back up, and all those things. And that really is a program. So each of these things that you have in Cobain are program, the schedule. Well, do you want it to run daily? Do you want it to run at a certain time? Is there a certain trigger? Before it runs the backup, do you want it to run other commands on the computer? You can set up all these different things and tell it exactly what you want it to do, where you want it to back up, and if there are problems, if you want to send emails or what you want to do. So this is an example, another example of a package that lets you code. Even though most people don't consider it code, you really are coding there. Okay, this is another example here. Most of us use an email system, and this is Gmail. Most of the email systems will let you automate tasks and create rules to forward mail, to delete mail, or move emails to make your life better there. And so this screen is just a little example. Within Gmail, you have the vacation responder, and you go in and you tell it, uh, first you can turn it on, and when you turn it on, then you can tell it exactly what you want it to do, the date range that it'll be in effect, only send to people that are in my contact list, so you can control it. And you're just filling out a form, but really you're coding. You're writing a procedure that's triggered to give you some kind of an output, and in this case, this output for the vacation is to notify people that you're on vacation. But again, the email could be forwarding. As an example, the PC Club has the mining at gmail.com. Well, I have those forwarded to my personal email so that I don't have to keep going into the mining email account to see emails that may have been sent to it. So I can automatically forward, I can put them in folders. If there's somebody I don't want to read their email, maybe it's a business and I can't unsubscribe, well, I can set up a rule that says every time this comes in, delete it or move it to this folder. So you can set up all kinds of rules. And as I mentioned a little earlier, use a Google search for any problem that you have with any package. You'll see this will give you ideas of what other people are doing to solve the problems. And usually there's some of these automated methods or some way of doing stuff. And if you try it, you'll like it. Okay, let's go into some of the basics instructions and coding. So when you code, there's usually a limited number of things really that you do. And one of the things is input. You have to get input into what you have. And that input may be from a keyboard, it may be from a touch screen, it may be data from a database, it may be a voice trigger like Alexa where you're telling Alexa what to do, or it could be a schedule, a certain date or daily or a certain time things are done. There's some kind of input. And so in addition to input, one of the other instructions, excuse me, is output. And that just means maybe you show a message on a screen, maybe you send an email to somebody, maybe you update a database. Can be a number of things. Turn a light on, certain things. The next thing is functions. So most languages come with functions, and these functions are things to do like arithmetic. It can be addition, multiplication, present value. You could do all kinds of things. Or it may be text related, concatenating text, searching for text, doing certain functions there. Dates, a lot of manipulation of dates and checking and things like that. Formulas, formulas are just more complex versions of some of the arithmetic or the text there. Just a wide variety of functions that are available. Another one is if-else conditions. And this is where, as you're going along in a program, usually you want to check a condition. If a condition is satisfied, you want to execute certain code or do a certain thing. Else, you want to execute some other code or do something else there. So it's important to have this if-else condition. The last major function in instructions is looping, and that's repeating until a condition is met. So and within looping you have things like go-tos, which is bypassing code and things like that. But looping is an important concept in coding. Next, this is just a very simple example of a flow chart. So this flow chart is showing what some code is doing. And this is code to figure out which of three numbers is the largest number. And so usually you, for complex things or that, you start creating flow charts. This is very simple, but it's important to, in some cases, diagram to show that you've covered all conditions, that you're doing the right thing. And this just shows some of those functions that we talked about, if else, printing, output, input, and then the end that's taking place there. And when, okay, so let's go, let's see here. Okay, computer languages. There's hundreds of computer languages, each with their own strength and weakness. And I talked a little bit about that at the beginning, and their own devices and platforms that they run on. If you're interested in the languages, I recommend you can start by going out to Wikipedia, and they have a list of programming languages out there. And this is by no means a complete list of programming languages, but I think there's probably about 500 or more languages listed out there. And so you can see in this, I just show some of the A's and the B's, and you'll see a lot of languages. Most of them I have never heard of. So they're just about every acronym in the world, but there's all kinds of them out there, all kinds of languages there. Let's talk about languages now, and let's talk about the 10 most popular languages that are used in the computer industry. And, excuse me, the number one currently is Java. And Java is mostly used for developing Android apps, web apps, and big data. Number two is C. C is used for operating systems, embedded systems, database management systems, compilers. If you're going to create a compiler for another language, you usually write it in C. Gaming and animation. Number three is Python. It's used in web and internet development. You have scientific and numeric applications. It's used in desktop GUIs, which stands for graphical user interface. It's used in business applications, and it's widely used in AI, artificial intelligence, and machine learning space. Fourth, C++. This is a variation of C, object-oriented version of C. It's widely used in game development, advanced computations, and graphics compilers. Number 5, Visual Basic. This gets back to those original days of the PC, the BASIC and stuff like that. This is still being used today in a number of things. Windows services, controls, control libraries, web applications, web services. C#, widely used in enterprise cross-application development and web applications. JavaScript, even though it has the same name as Java, it's quite different than Java. JavaScript usage include web, mobile, app development, game development, and desktop and app development. PHP, web development, content management, e-commerce applications. Number 9, SQL. SQL's been around for 30 years, 40 years. Used in most databases to find data, to update data, to do all kinds of functionality with databases. Object-C, Apple's. This is what most of the Apple stuff is written in. The Apple operating system and APIs, Coca and Coca Touch. Now there's all kinds of other popular ones, and I'll list just a few of them here, and we really won't go into detail here, but you can see there's all these different languages, and some of them are for a particular platform or device. Some of them were created by large companies like Google or Microsoft to solve a problem and for their people to easily code and automate procedures. So you have all these different reasons for all these different languages created there. Elm, Go, Groovy, Kotlin, Perl, R, Ruby, and then you have Ruby on Rails, Rust, Scala, Shell, Swift, TypeScript. Lots of different languages, lots of different variations, and they all have their uses. So there isn't one language that is used universally for everything. There's literally these hundreds and hundreds of languages. Okay, if you are interested in classes or learning more about languages, the nice thing is most of them are free. You can start learning about all these different languages and how to code and do things. And I list a bunch of resources here. The first one is the Khan Academy, and then there's Code Academy and Course Guru. These are the most popular sites for doing education related to coding and the capabilities that can be done there. I know I covered that pretty fast. I didn't want to go in. I struggled a little bit how to approach this topic, and I didn't want to go into a lot of detail. So I hope I gave you some information about it, and now we'll open it up to questions. So you can turn on your video and unmute your audio if you want, and we'll see if there was anything in the chat to also try and cover some things there. So let me stop sharing so we can see everybody then too. Okay. Does anybody have a question or a comment there?
I do, Tom.
Sure.
Can you use coding in Excel?
Yes, you can. I mentioned Microsoft over the years, starting with almost the first version of Office and even within Word when it was a separate package, you have capabilities in there to code. And there's different degrees of coding, so you can create what are called macros in that within the Office suite. Those macros can actually cross the boundaries. So and cross the boundaries of the different Microsoft packages. So an Excel spreadsheet, I believe currently, I don't know if Paul Ebert, our membership secretary, is on, but I believe he wrote a few macros to maintain the PC Club database. And in the PC Club database, he enters them into Excel, but each month when he wants to send out or expiration reminders and dues, he just runs a macro. That macro goes through the spreadsheet, looks at different values in the spreadsheet to determine, gee, you haven't paid in the last year. It'll collect that information. It'll actually create an email and send out an email. So you can start automating between different packages using data and presenting there.
Thank you.
The other thing I'll mention, the way a lot of people start out in Excel or that is you can also just go in and you can record keystrokes. So you can use it like a recorder. And so if there's a function that you're going to be doing repetitively, maybe it's you got a document and you want to delete 4 spaces here and do this, you can record that and then you can play that back at any time. And so that's usually the way people start out in Excel, or that is they'll maybe start recording something that they do so that they don't have to repetitively do it again and again and again and again. They'll record it and then play it back. And once you record it, you can actually go in then and edit it and add things to it, or you could re-record it or do all kinds of things there. Now, some people, and if it's a more complex thing that you're doing, even myself, I don't start from scratch. A good programmer never starts with a blank slate of nothing and starts writing code. So I do a search to see if there's something out there that does something close to what I want. Or as an example, I'll do a Google search, I'll find a macro. So you'll find all kinds of spreadsheets and macros and things like that out there for different things. And you can start with that, and then you can, if you want to get into a little more detail or don't like the particular way that they're doing something within the macro, that's where you can go in and edit. So you do have lots of capabilities with some of this stuff there. Okay. Let's see. I see Paula asks, what language is used in the Raspberry Pi? That I don't know. Raspberry Pi, for those not familiar, is just a little device there. And I believe on the Raspberry Pi you can load an operating system. And so that operating system is like the Android operating system. And so basically the same things that you can do in an Android, you can do there. You can also add additional statement or recordings and things like that. But I'm not sure if by default it has its own language or you have to add a language in there.
Yeah, the reason I asked is a lot of the students in the science fairs that we 3Mers judge, they have Raspberry Pi devices. Maybe they're using Python, because I know that Python is or SQL. Those are popular languages for these students to use. But also the one that's associated with AI, it might be because sometimes they're using the Raspberry Pi for the machine learning.
Yeah, and that's a good examples there, and the thing it kind of be like saying, well, what language would you use on a tablet or a smartphone or a PC? Because I could use 1,000 different languages on those. It just depends on what I'm trying to do. If the Pi, let's say the Raspberry Pi, I have set up to uh, collect acceleration of a device, and write that to a database. Well, that's one feature. Another feature might be that I want to use the Raspberry Pi to detect other devices that are close to me. So it has to talk to a video camera and do different things. And again, depending on what you're trying to do, a certain language or that is going to be more advantageous or easier to do than another language.
Sounds good. Thank you.
You're welcome.
And Python is the official language, but like you say, yeah, I'm sure any given Raspberry Pi could be set up to use other languages.
Right. I've heard of a small Raspberry Pi being used to update a website, let's say. Well, the way that you update a website and put some information out there, well, you're under the constraints of what you're doing there. So some people will use, like, if you've heard of FTP, to send data up to a website, or different ways of doing stuff there. Okay.
And you got rid of the echo.
Okay. Yeah, sometimes the echo is kind of an interesting thing. If you've been involved with computers a long time, the original voice over IP or VoIP telephone calls over the internet, those had a lot of the echo and that. And the reason is today on your computer you have a speaker that's you hear my voice now, but my voice is coming out of your speaker, but then it's also going back into the microphone on your computer. And the software has to be smart enough to try and take out my voice before it sends back your question or things like that. If it doesn't, there's always going to be a little delay, and so it sounds like an echo, because my voice is I give my voice, it goes into your computer, comes out of your speaker, goes into the mic, goes in there, gets sent to everybody, comes out of your speaker again. And because there's milliseconds or fractions of a second to transmit this stuff, that's why you get echoes. In the original days, what we'd force people to do is we'd force people to put on a headset. So then your speaker only goes into your ears, it can't get back into the mic. And if you've watched, even today, if you've watched people doing Zoom calls and things like that on TV, you may have noticed that a lot of them have a headset that they use, or they have wireless earpods. And the wireless earpods serve the same function. The sound is going directly into their ears and doesn't have a chance to go back into their mic, back out to everybody. So it reduces the chance of an echo, and the software that's trying to take out that echo doesn't have to work hard, or doesn't have anything really even to take out. But when software can't take it out, that's where you get the echo.
Tom, this is Linda.
Yeah.
And during that very wonderful discussion I bet you just had, I got a phone call, which was devastating, because the plumber who was supposed to be coming to fix my very leaky faucet now canceled until the end of January. So anyway, that's another story. But I've been wondering about that on TV and why people are choosing to wear the little white ear things that hang out of their ears or the headphones. And so I caught the tail end of this discussion, and that's wonderful to know that that's part of that echo effect that we get.
Yeah, the echo not only does it help with the echoes or prevent the echo from occurring, but also the wireless ear pod. So the sound that normally comes out of your laptop or out of your phone or that goes directly into their ears, but also the mic is right up by their face, as opposed to on the laptop you may be sitting back from the mic, or the mic may not be that well. So actually it's a double benefit there. Both the mic is going to be better, and the sound has no chance of being an echo there. So
that's when I see somebody who actually has a a little mouthpiece in which they can speak right coming from their ear or around their neck or whatever. That's another thing to think about. You forget here who you're talking to, though. I do have headphones, but they plug into my laptop. Would that make any difference if I were to experiment? Because when you say that they would work, are you frozen there or just holding really still?
no,
there you go. Okay. So for in the future, if I heard that echo, would it be worth my while to go? We've talked about my headphones that I won at the door prize at our summer picnic, but it's a plug-in version. So if I were to listen to a meeting using those headphones with them plugged in, would that resolve an echo situation if I ever had it?
Yes, it would resolve the echo that was caused by your computer. Now, if you're on a meeting like this where we have numerous people, it could be an echo problem with any of the people on the meeting here. So you may be fine, but if your PC is causing the echo, plugging in headphones is going to resolve it so that your computer isn't causing the echo. Doesn't mean that somebody else on the meeting is causing the echo.
Thank you. Good to know.
Okay.
Good to learn.
No. Any other questions on coding or the coding? Just if you hunt around in the various packages, you will see these different, maybe it's in the settings or maybe it's in the tabs or somewhere there. A lot of them do have the capability that allow you to be able to write the very basic type coding there, where you can have a function, you can ask a question, you can do something, and it's not as hard as most people think there.
Tom,
Yes.
I was blessed with a gift card last Christmas for $50 at Barnes and Noble. And the other day I said, I better cash that gift card in before Barnes and Noble goes away, because I can't believe that they're still in existence. But I went over there and I bought two books. One is Coding for Beginners, and the other one is Coding All-in-One Dummies. And I think they're both, from what I've been reading, they're both pretty good. And I know that it does suggest that you can go on the web and just download a bunch of different languages, and but I haven't done that yet. But anyway, I just thought I'd throw that out.
No, that's good there. There's a number of people that are retired are looking for things to do and stuff like that, and I think I mentioned in this topic, I said you can make your life easier. So if there are things that you're doing on a repetitive basis or things like that, that's where these languages and looking up, if you have Alexa, the capabilities there. All these packages that we have come with all these features and functions, and most of us don't use much of any of it. So the more that you learn about it, you'll find that there's shortcuts, there's ways to automate things and solve all these problems or make life easier for what you're doing there. And the languages are an interesting animal because there have been so many over the years. You may have heard of some of the languages are what are called interpretive, and others are compiled. And so the difference between an interpretive language and a compiled language is how those instructions are converted to machine code. So in order for your instruction to do something, it has to be converted to machine code to figure out what to do. Well, if it's an interpretive language is decoded each time you run it. So when you run it, it tries to figure out what it should do on the machine each time. That trying to figure out what it should do takes time. And in the early computers, that meant that something might run very slow. So the difference between an interpretive language meant that it would run slow. You wouldn't build an operating system out of an interpretive language. You wouldn't build something where you wanted speed out of an interpretive language. So what they did is they created what are called compilers, and the compilers look at that code that's written and convert it to machine language and then store it as machine language. And that's what you see if you've ever looked at like an operating system and seen things like a .exe file or a DLL file. Those are machine languages from a language that was compiled into this. That means that when they're run, it doesn't have to interpret each character or each command. It's already converted, which makes it hundreds of times faster than an interpretive language. Now, we still have interpretive languages just because computers have gotten faster, and the process of doing a compile of a large program, in some cases, can take 30 minutes to compile a program because it creates memory spaces and does error checking and boundary checking and all these things there. So compiling is a slow process to do, but you end up with usually the fastest running code possible. Interpretive is very receptive to making changes. So this time you change this and then you run it, and then you change something else and you run it. And there's even versions of languages like BASIC. I used to write in BASIC and use an interpreter. When I got it to the point that I liked it, then I'd use a BASIC compiler. The BASIC interpreter came with DOS, so you had this BASIC interpreter there. But if you wanted to compile your BASIC, you had to buy a BASIC compiler, and Microsoft sold that for, I think at the time, this was back in the 80s, they'd sell it for about $400. So compilers have their uses, and you'll see languages out there and all kinds of things there. Any other questions or comments there? But I'd challenge everybody to use some of the packages that you have and see about automating some things. So if you do have an Alexa, think about some of the things to automate.
Tom?
Yes.
Dick Weiss here. Got an issue with this Microsoft Teams. To get the audio and the pictures on, I had to open up a second window off of the bar at the bottom of the screen. Is there any way that set it up so that it'll start with the audio and video?
It again kind of depends on how you have Microsoft Teams installed. Microsoft Teams, you can install a full version of Microsoft Teams on your computer. Or you can choose not to install the software and run it through a browser. So the capabilities and how it works through a browser are different than if you have the full version of Teams installed on your computer. You get more options and more features if you install the full version on your computer. Then what you should see, like what I see on my computer, I've installed the full version of Teams because it doesn't cost anything. It's just, it does take up space on your computer and that, but there's no cost for a free account. When I start it up, I get a preview screen where I can adjust my video and I can choose whether to join with my video or with my audio or with both of them. I choose how I want to join there.
Okay, so I guess that's the issue.
Yeah, and
Thank you.
The other thing with Teams like Zoom and some of the others is if you install the software, the Zoom software, and not using Zoom through a browser, which doesn't install the full version, doesn't have the full version, you're going to have more features and functions for some of the things, maybe like backgrounds, also the testing of the audio connection and the video, and setting the quality and some settings in there that you don't have if you don't install the full version there. And then there's even differences. Even though I installed the full version of Teams, because I have a free version of a team account, that doesn't unlock all of the features and functions. The 3M active 3M employees have a lot more features and functions than what I have access to. So I'd have to buy a subscription to Microsoft Office or to Teams itself to get more capabilities there. Okay.
And this is Jim. I'll make a couple comments too here.
Sure.
I don't know if it's a new security thing, but I cannot attach a file in the chat right now. And I don't know if it's because we have people outside the organization that are in the chat now. So anyway, I can't attach a file. I could attach it yesterday before, I actually started the meeting yesterday and I could attach a file then, but so I can't attach the file. You'll have to go to the website to get the handout. And then back to the topic we were just discovering. Yes, sometimes it just ends up being a glitchy connection, and it's the theory of reboot. So you leave the meeting and rejoin, and you'll get the sound and audio. That happens in Zoom too. And Richard, if you're having trouble, or Dick, sorry, but I see Richard on the screen. If you're having trouble, right, your camera is on right now. If you're having trouble with bandwidth, if you sometimes then shutting your camera off will help you with that too.
I just picked up an echo, so I don't know where that came from.
And I think the echo is actually on Tom's side when one of the other participants speaks, because Tom is using a microphone, not using a headset. That's where the echo is coming from.
Yeah, I'm using a headset.
Okay.
Thank you.
Well, I think if there's no more questions, we'll end the meeting. And again, we've got the MACSIG coming up on Friday if you're interested in that. Otherwise, have a Merry Christmas and a Happy New Year's, and we'll see you in 2021 then. Okay. We'll see everybody.
Tom.
Bye.
Thank you, Tom.
Yep.
Hey, that great presentation as usual today, Tom. Thank you so much. I don't know that I'm going to rush out and start doing some coding, but Boy, I remember trying to learn that stuff in my early days at 3M, and why you're a person doing that job and I am not. But it
Oh,
looked familiar, and you do such an excellent job at laying out, even for those of us who struggle to understand. You're making sense with what you're saying, and so you give us a good starting point, and there are moments that can actually relate to experiences in the past that have reflected the coding, and it's exciting to see what things can be simple and at our fingertips once you make the whole plunge into making improvements in your environment that take you into the 21st century. But there's a lot out there, and interesting ways, I guess, just even smart plugs. I might start with something like that and experiment and see what I wouldn't be able to talk to anybody, but I would be able to, through Bluetooth, give commands off my laptop, maybe, or not. Do I need a voice in my house, one of those little talking boxes?
yep. You can, well, the boxes themselves, the Alexa Dots, you can get them as cheap as $20. So,
I see that, and so I would have to introduce one of those into my environment to get the total connection between smart plugs and things like that.
you
Yeah,
could do it. You could do it without it, but if you had a smartphone, you could do it just with a smartphone. But the devices are nice because they're always on and they're always there.
Well, when they can start making meals for me when I need dinner, that's, I think, when I'll get them in the house. So
They
you
can
let me
do that.
know.
They can turn on the oven. They can. Okay, we'll talk to you later then.
Thanks, Tom, and happy holidays to you and your family.
You too. We'll see you then.
Bye now.
Amazon third generation, $24.99. I just put one in my cart. I'll buy it after work today, but yeah, I thought that'd be a good gift for someone. $25 for generation 3 on Amazon.
Yeah,
Sure.
there's good deals, and if you don't have like the Echo Show 5, those were going for like $44 or $42. That's a 5-inch screen on there, and so it's like having a dot, except you've got a 5. I can watch TV, so I'll put on the news or that on there, and if you have security cameras, you can switch. If they're compatible with the Alexa or that, you can switch and watch the front door or things like that just from that too. So it's amazing what you can do.
That your background, going back to your background starting in the 70s, that really is fascinating. My first time with computers was in 1983 in college using Fortran, and we did have to use the punch cards. And you had to keep running up to the lab, put your cards in, and then you get a result. It didn't give me the quadratic equation like I wanted, so I'd have to tweak a couple things and then go back up a couple times. Big, huge computer room, too.
The whole second floor, or most of the second floor, and building 224, well, about 3/4 of the floor used to just house punch cards. There were filing cabinets full of punch cards. And there's a procedure for doing updates to those punch cards where you were supposed to submit a change request and things like that. But I was working with an old timer there. He'd go down and he'd distract the security people. I'd sneak back in to the decks and insert our cards in where we wanted our cards. So we had it all figured out how to make our changes. Otherwise, if we wanted to get in a change, it may take 2 days or something like that to get it in. We'd get it in and bypass.
Oh, wow. That's pretty cool. Well, you made that a career. Other people have as well. I was glad to just pursue engineering and not computers.
No, no. Okay,
Pretty
well,
cool.
we'll see you then. Yep,
Thanks,
bye.
everyone. Bye.